All right, let's talk about one of the most maddening things in networking. You've set up your static routes, everything should be working, but when you send a packet out, it just disappears into the void. Today, we're going to figure out why.
You know the feeling, right? You send a ping, you try to connect to a service, and you get absolute silence. Not even an error message. It's like your data just ceased to exist. Well, that little mystery is exactly what we're going to unravel. So here's the mission. We're going to follow a packet step by step from its source all the way to its destination. We're going to learn to think like a router, and by the end, you'll have the exact toolkit you need to find out where things went wrong. First, let's look at the happy path. When everything is configured perfectly, how does a packet actually make its way across the network? See, it's not random. Every single router it meets follows a very specific logical process to decide where to send it next. Let's break that down. Okay, imagine a packet needs to get from PC1 over to PC3 on a totally different network. PC1 sends it to its gateway, let's call it router R1. Now, from that point on, every router in the chain does this exact same four-step dance. It gets the frame, unwraps it to look at the destination IP address inside, and then it checks its map, its routing table, to figure out the very next hop on the journey. Now, this is the really crucial part. When the router looks at its map, it has a strict order of operations. It is always looking for the most specific route first. So if you've manually created a static route that perfectly matches the destination, the router will use it, no questions asked. Only if it can't find a specific match does it then look for a default route, which is kind of like the route of last resort. It's the router's way of saying, well, for anything else I don't have directions for, I'll just send it over here.
And that brings up the big question, the one that's key to our whole mystery. What happens if a router checks its map, finds no specific route, and there's no default route configured either? What does it do then?
The answer is simple and, well, pretty brutal. The packet gets dropped. The router literally just discards it. Now, it usually doesn't do this in total silence. A well-behaved router will send an ICMP destination unreachable message back to you. That's the router yelling back, hey, I have no idea how to get where you want to go. So, assuming our packet survives its journey across all those routers, the final router in the chain, R3, has one last job to do. It knows the destination PC is on its local network, so it uses something called ARP, Address Resolution Protocol, to basically shout out to everyone on the local network, hey, who has this IP address? PC3 hears that, replies with its physical MAC address, and boom, R3 can deliver the packet right to its final destination. So if this whole process is so logical, where does it all go wrong? Why do our static routes fail? Well, assuming it's not a physical problem like a bad cable, the answer almost always comes down to one thing: human error. And you'd be surprised how simple these mistakes usually are. A single typo in the next hop IP address, using the wrong subnet mask, or a classic one, you configure the route in one direction, but completely forget to add the return route on the other side. Any one of these tiny little slip-ups will completely break the communication path. And this really gets to the heart of the problem with static routes. The clue is in the name. They are static. They don't change. If a link they depend on goes down, that router has no idea. It'll just keep faithfully sending your packets down that now broken path right into a black hole. It has no way to adapt on its own like dynamic routing protocols do.
Okay, so when your packet vanishes, it's time to put on your detective hat. You can't just sit there and hope it fixes itself. You need a set of tools to investigate, and luckily, there's a core set of commands that are absolutely essential for this kind of work.
These 5 tools are your best friends. You almost always start with ping. It's the basic sanity check. Can I even reach this thing? If that fails, traceroute is your path mapper. It shows you exactly where the journey is ending. To make sure the lights are on, show IP interface brief confirms your physical ports are up and running, and show CDP neighbors gives you a reality check to see what's actually connected. But the real star of the show, the most important command by far, is show IP route.
This is it. This is your window into the router's brain. This command shows you the exact map the router is using to make every single decision. If that map is wrong, your packets will go to the wrong place, period. Mastering this one command is the absolute key to solving these kinds of problems. All right, enough theory, let's solve a real case. So here's the scenario. PC1 can't reach PC3. We've done a quick ping and a trace route, and it looks like the trail goes cold somewhere around the second router in the path, router R2. So what do? We log right into R2, and the very first thing we're going to do is look at its map. We'll run our favorite command, show IP route, and see exactly what instructions R2 has for getting to PC3's network.
And there it is. Right in the output, we see a static route, that's what the S means, for the correct destination network. But take a close look at that via address. That's the next hop IP. That is the exact address R2 has been told to forward the packet to. And that's our big clue.
And that's the whole problem right there. The configuration is telling R2 to send packets for our destination to 192.168.1.1. For all we know, that could be back where the packet came from. It's definitely not the correct path forward. The router thinks it's doing the right thing, but its map is just plain wrong. So the fix is actually pretty simple. We just remove that incorrect static route command, and then we add the correct one, making sure to point it to the proper next hop IP on the next router in the path. Let's say it's 172.16.2.1. We are literally just correcting the directions on the router's map. And really, the takeaway here couldn't be clearer. Troubleshooting this stuff isn't some kind of black magic. It's a systematic process. It's about using these commands to think like the router and verify the path at every single step. And when it comes to static routes, it almost always begins and ends with making sure the map, the output of show IP route, is 100% correct.
But that leaves us with one final nagging question. What if you do all that? You check show IP route and the map looks perfect. You check your interfaces, they're all up and up. A trace route even shows the packet getting to the final router, but the ping still fails. What could it be then? When the routing itself seems flawless, what's the next layer of the mystery you'd start to investigate? That is where the real fun begins.